Hello students, myself Sooryaraj, Faculty of Physics. Today we are going to start a new chapter. The chapter name is Moving Charges and Magnetism. This is your fourth chapter. I am repeating the word moving charges. What do you mean by moving charges? Yes, electricity. Moving charges means electricity and magnetism. So this chapter deals the relation between electricity and magnetism. So in this chapter we will discuss the relationship between electricity and magnetism. The relation was first discovered by scientist XII. So now we are going to discuss the experiment conducted by XII. Okay. So now we are going to discuss how can we relate electricity and magnetism. This is the experiment conducted by XII. Now we can consider a circuit like this. This is an electric circuit. Okay students, this is our electric circuit. Below that circuit you can see a compass. We know that a compass consists of two needles. What are they? Yeah, the needle will represent north as well as south. So we can represent here north as well as south. Here you can see a cell and this one is a key. From the figure itself, it is clear that the key is open or the circuit is open. When the circuit is open, no current will pass through the circuit. So we will not represent direction of current because current is not passing through the circuit because the key is open. It is not closed. This is an open circuit. At this time, when current is zero, that means when no current is passing through this circuit, there is no deflection in the compass needles. The compass needle north and south are parallel to circuit. These are parallel. This can be considered as our first figure, though this is figure A. Then we are going to our next step. The next step conducted by the scientist is that the same circuit is repeated. The same circuit. Okay. Here from the figure B, this is considered as our figure B. In this figure, we can observe that the key is closed. The key K is closed. That means that is a closed circuit. When the circuit is closed, what happened? Current will start to flow. Isn't it? What is the direction of electric current? Yes, electric current will flow from positive and to negative. So we can represent direction of electric current as shown in the figure, and electric current is usually represented by the letter I. So now current is flowing through this circuit. At that time, you can observe a deflection. You can observe a deflection here. In this figure, there is no deflection. The needle is parallel to electric wire, north and south. But in the second figure, that is figure B, when the key is closed, when the current starts to flow, the compass needle shows some amount of deflection. the compass needle show some amount of deflection. Why they get deflected? What will be the reason? Yes, a current carrying conductor produce magnetic fields. This is a current carrying conductor. Current is flowing through that conductor. A current carrying conductor will produce magnetic fields. That magnetic field is responsible for deflection. The magnetic field produced is responsible for the deflection in our compass needle. Okay, so this is the relation between electricity and magnetism. Electricity can produce magnetism. The experiment is a proof. This is the experimental proof of a relation between electricity and magnetism. So, we can conclude this session by saying that a current carrying conductor will produce magnetic fields, and that magnetic field is responsible for deflection. Actually, this is not a deflection. This is vibration. When current is flowing through that circuit, the needle, compass needle, undergo vibration like this. Okay, so that is represented as deflection. Actually, that is not a deflection, that is a kind of vibration. Ready? So now we can enter into our chapter. Our chapter name is Moving Charges and Magnetism. Otherwise, it is also called as Electricity and Magnetism. From the figure, I can explain that heading, Electricity and Magnetism. Okay, so before entering into magnetism, I want to revise some concepts, that is electric fields. I think you have already learned about electric field in your first chapter, isn't it? Electric charges and fields. But I will explain it one more time for you. So please listen. Now we are going to we are going to revise the concept of electric fields. Ready? To explain the concept of electric fields, I need a charge. Okay, so let us consider a charge. Q is our charge. This Q is a point charge. We know that like charges repel and unlike charges attract. Okay, this is a charge, either it is positive or it is negative, whatever be it. This is another charge in my hand. This is a point charge and this is another charge. When I place it here, there will be a force of interaction, either an attraction or a repulsion. Okay, so this is our point charge and is another kind of point charge. When I place it here, they will experience force of interaction. But when I am moving like this, the second charge is moved like this. At that time, force of interaction decreases, isn't it? When the distance increases, force decreases. Okay, so when I am moving my charge like here, this is my charge. When I am moving this charge, the force of interaction decreases. Then at a particular point, the force of interaction becomes zero. Here it is maximum. But when we move away at a particular point, it become zero. The force of interaction becomes zero. When I place another charge here, outside this boundary, there will be no force of interaction. But when I place it here, there will be a force of interaction. Okay, so there is a boundary. around a charge. There is a boundary around a charge in which force of interaction is experienced. I am going to mark that boundary. There is a boundary. This boundary around a charge is technically called as electric field. When I place a charge outside this field, there will be no force of interaction. Okay, when I place it here, outside the boundary, there is no force of interaction. But when I place inside the boundary, either there is repulsion or there is attraction. So this is technically called as electric field. So electric field is an area around a charge in which its influence is felt. Influence means attraction or repulsion. So how can we define electric field? Yeah, electric field is an area around a charge in which its influence is felt. What do you mean by influence? Either it is attraction or it is repulsion. Beyond that boundary, there will be no force of interaction, no attraction, no repulsion. But inside that boundary, there will be force of interaction, either attraction or repulsion. Okay, this is the concept of electric field. Then we want to enter into our topic magnetic fields. We will discuss it in our next class. Today we have discussed the two topics. Our chapter name is moving charges and magnetism. What do you mean by moving charge? Electricity and magnetism. The relation was discovered by scientist XII. Then we showed the explanation, experimental setup conducted by XII. Then we have explained the term electric fields. Okay, the magnetic field will be discussed in our next class. Thank you.